process how to calculate t-test for correlated mean. Last class we have done the correlated mean procedure for single group. In case of single group, when we have small sample which is mean less than 30, in that case we go by a different process called the difference method. What is the difference method? Here we will find out the difference of on a particular like set of score, the difference on the scores, and then from that we find out the mean and the standard deviation. So let's take an example. Example is like there are 12 subjects n equal to 12, okay, and they are given a test, okay. So on that test many trials are taken, no, and their trial and their scores are obtained. So we want to see whether some significant differences are coming with the trials or not, okay. For example, we have taken the score of trial 1 and score of trial 5. Now you can see that there is a difference in the scores from trial 1 to trial 5. Sometimes it decrease, sometimes it increase. So we want to find out whether there is a increase, significant increase in the mean of trial 5 with the trial 1. So here we can go by a process called difference method. What we will do here we will first find out the difference. Before finding out the mean, we will find out the difference between the scores obtained by the single person in this initial trial, which is trial 1 and trial 5. So there are 12 subjects. So this is the score of subject 1 in the first trial and in the 5th trial. So we'll find out here first the difference, which is called the difference. That's why this method is called the difference method. So 62, 50 minus 62, so we'll minus the initial the score of trial 5 minus trial 1. So it is the trial 5 minus 1. So 62 minus 50, that's why it's plus 12. 40 minus 42 minus 2. 61 minus 51 plus 10. 35 minus 26, that is 9. 30 minus 35 minus 5. 52, 10, 8, 10, this is 14, and 62 minus 55, this is 8, 10, and then again 12. Okay. Now what we will do, we will take the we'll find out the mean with the help of this difference, okay. So here if we total the positive in one side and the negative values in one side and then subtract the value, then it will come out as 96. How this 96 has come? It is one side you will be totaling all the positive value and one side you will be totaling all the negative values, means 2 plus minus 2 minus 5, we have only 2 negative values, so minus 2 minus 5 means minus 7, and all the other positive value, so their total minus 7, so this is 96. So this 96 now will be divided by n, which is 12. So it is 8. So now for this group the mean will be, we'll take a single mean value, so that is mean is, we'll call as mean difference actually is 8. Now we will find out the x, small x, that is the deviation of the scores from the mean. So here we will find out the deviation of mean from this scores. So 12 minus 8, 4 minus 2 minus 8, that will become minus 10. 10 minus 8 2, 9 minus 8 1, minus 5 minus 8 will 13, 2, 0, 2, 6, 0, 2 and 4. Okay. So then we will do squaring of the value. This will be 16, 100, 4, 1, 169, 4, 0, 4, 36, 0, 4 and 16. So this we will find out summation of x square, because this we need to find out the SD value is 354. So we got the summation of x square, because this one we need for calculating the standard deviation value. So we will calculate the standard deviation. First the standard deviation. Standard deviation with square root of summation of x square divided by n minus 1. So here summation of x square is 354. This one is the value. We will put it here, n minus 1, that is 12 minus 1. Okay. So this will become the 5.67. 5.67. So 5.67 will be the SD. Now we need to calculate the standard error of D. The standard error of difference we will calculate by the formula. Standard error of D is equal to SD divided by square root of n. So SD we obtain here 5.67 and square root of n is 12. So the value will become 1.64. Now the t value, we can easily calculate the t value. Here t will be the mean difference. Mean difference is here, we have calculated. This 8 will be considered as the mean difference, because here we already find out the difference of the scores and then we have calculated the mean value. So this 8 is the mean difference here, divided by the standard error of D, that is 1.64. So the value is 4.88. Now for correlated mean, the DF formula is n minus 1, because same group is with the same group we obtain data 2 times. So it will be only n minus 1. So here DF is 12 minus 1 equal to 11. Now for 11 DF, from the T table we will check the table value of T. So for DF 11, from table D, the T values are at 0.05, level is and at 0.01, level is. Okay, what we will do, as you can remember the question that was asked, that is the mean gain, is there is any kind of gain has been done from trial 1 to trial 5. So the hypothesis is actually directional, that it was asking about only the direction which is in the positive side. So what will happen when we will try to find out the value at 0.05 and 0.01 level? Actually we need to check the value at 0.02 or for 0.01 level we have to check the value at 0.02 column, and for 0.05 level we have to check at 0.10 column, because one tail test, so all the value will be remain at one side of the NPC curve as per the concept of NPC curve. So you can see in the table there are four column, 0.10, 0.05, 0.02 and 0.01. So in case of one tail test we have to check the value at 0.10 column and 0.02 column. So for 11 DF the value is 1.80, and for 0.02 column the value is for 11 DF is 2.72. So what we will do, this 2.72 the value will be the value for 0.01 level of significance. So 2.72 we'll write here, and the value which is at 0.10 column will be the value for 0.05 level of significance. So 1.80. So this is the value that we got from the table for 11 DF. Now our obtained t value is 4.88. So 4.88 is larger than this 1.80 and 2.78. So our obtained t value is significant. So we'll say that our obtained t value is larger than table value at both level. Therefore, you need to write it like this. Therefore, the obtained t value is significant. So this way we calculate t with the help of the difference method in single group small sample. Thank you.